Okay, let's unpack this. We've all been there, right? You're out somewhere, maybe you way off the beaten path, or heck, even just a weird spot in town, and bang, no service. So imagine a world where those dead zones just, well, vanish completely. Today, we're doing a deep dive into AST SpaceMobile. They're making some pretty bold claims talking about real global connectivity, space-based cellular broadband straight to the phone that's already in your pocket. Our mission here is to figure out how they plan to eliminate these gaps, covering, over 90% of the Earth?
Right.
And what that really means for, billions of mobile users like you. Can they actually do it? Yeah, digging into this, the numbers are just, wow, the scale of it all. I mean, did that hit you too? Right now, something like 42% of the world doesn't have cellular broadband at all. And even for the 5.6 billion people who do have phones, those coverage gaps are just maddeningly common. So AST SpaceMobile, they're not chasing some small niche here. They're aiming for a piece of that $1.1 trillion global wireless market. And projections for this direct-to-device stuff, D2D they call it, could be up to $137 billion by 2032. That's huge.
It absolutely is. And what's really fascinating here is how AST SpaceMobile plans to tackle it. Your unique angle, the real game changer, the things setting them apart.
Yeah.
Connecting directly to standard, totally unmodified smartphones.
Right, so no special equipment needed on our end.
Exactly. Your phone, right now, using the existing cellular spectrum. No new hardware, no dongles, nothing. And the how is these patented, absolutely massive phased array antennas they put in space. Their prototype, Blue Walker 3, it unfurled successfully 693 square feet. I mean, that's bigger than a lot of city apartments.
Wow.
And the commercial ones, the Bluebirds, they're designed to be even bigger. We're talking 2,400 square feet.
Okay, that's enormous. Like half a basketball court, you said?
Pretty much. And that scale, that sheer size is key. It lets them act like a cell tower, but from orbit, powerful enough to reach that tiny antenna in your standard phone. It's complex tech.
Yeah.
Backed by over 3,650 patent claims.
Yeah.
Really speaks to the innovation involved.
Incredible engineering. But, the best tech needs a smart way to reach people, billions of people. Mm-hmm. Their business model seems pretty clever, actually. This wholesale B2B2C approach, partnering with the big mobile network operators, the MNOs, AT&T, Verizon, Vodafone, Rakuten Mobile, the carriers you already use.
Right.
So that gives them access potentially to nearly 3 billion subscribers almost immediately. Huge head start.
It's a massive built-in customer base.
Yeah, they call it a partnership moat, right? And it seems validated, too, with investments from Google, AT&T, Vodafone themselves. But partnerships can be tricky. Any potential downsides there? Dependencies?
That's a really good point. I mean, the partnerships give amazing reach, but scaling globally means those MNOs need to integrate ASTS's service into their networks, their billing systems.
Right, that sounds complicated.
It's a big lift for everyone involved. And if we connect this to the bigger picture, well, the competitive landscape is intense. Yeah. You've got SpaceX's Starlink as a major rival. Now, their direct-to-cell is currently more focused on SMS, MMS, basic messaging.
Okay.
AST SpaceMobile, though, was engineered from day one for actual cellular broadband. High-speed data, voice calls, the works.
So a different initial focus.
A different initial focus, exactly.
Yeah.
You also have players like Link doing lower bandwidth stuff, and Apple with Global Star for just emergency SOS on proprietary devices. But, and this is important, the risks for ASTS are significant. Deploying and operating these huge complex satellites, that's hard. They need substantial future funding, serious capital to build out the full constellation.
Right.
And then there's the whole global regulatory maze.
Yeah.
Getting licenses in potentially hundreds of countries.
Yeah, that sounds like a nightmare.
So it really is, as you said, kind of a high-risk, high-reward situation.
Yeah.
Massive investment needed, but balanced against those potentially sticky, huge MNO partnerships. It's a race, really, against time, against capital burn.
Okay, so lots of moving parts, huge ambition. What does this actually mean for, you listening right now? Well, initial commercial service might actually be quite soon. They're launching their first 5 Bluebird satellites. And the goal is, I think, continuous coverage in key markets starting around 2026.
That's the play.
So if they pull this off, if they navigate those challenges, it could genuinely change how, and maybe more importantly, where we all connect.
Yeah, and that brings up a really interesting question to think about, doesn't it? If this works, if we actually get true global connectivity, finally eliminate those dead zones everywhere, what happens next? How does that reshape things beyond just communication? Think about economies, education access, emergency response for potentially billions of people. What's the real ripple effect when you connect literally everyone, everywhere? Something to ponder.